record this because this is an important procedural change. For a couple of different reasons, I've decided to try an experiment. Don't panic. But I'm going to start giving some questions that are point-based, that are correctness questions for the Google form. The sum will be not just participation, but are you correct? We're going to start simple and we'll build up to deriving the Lagrangian for quantum mechanics, but let's start simple. Are you ready for your first question? That is actual, it's got to be right. If you don't get these right, you actually do not get any participation points for the day. Capiche? But don't panic. We're going to start simple. Derive the quantum mechanical Lagrangian. Just kidding, just kidding, just kidding. How many fingers am I holding up? This is the first question. Put this in Google Form A. If you don't put this in Google Form A, and I want a single numeral, I do not want you to write out the word. I want a single character, the single number from 0 through 9 of the fingers that I'm holding up, and no, in my pocket they're still down, okay? If you do not get this correct, you will lose half of your participation points. Also, the last question of the day will also be a question that if you screw it up, you will lose another half of your participation points. Let's see how many people were able to follow instructions. Oh, this also doubles for please be on time and please don't skip out early. And if you're participating, you're attending class, then you get full points. Okay, congratulations to the 78 people who are listening. This is important, and I'm going to be using this to beat you into submission of, train you, you into answering in the way I want you to answer some questions. I've had some difficulty with people not listening to directions. I'm hoping that this will partly help with that. But again, I want to emphasize also, yes. This is going to be machine graded. So if you don't enter in the format that I specify, if you do not listen and specify in the format, it will not grade you as correct. It will not accommodate incorrect formatting things. So like I told you, it's got to be, you can't spell out THREE. Oh, gave the answer right. You have to give the number. Well, I'm going to be training you, and we're going to be practicing some other things. Well, we're going to be practicing one big skill today. Today is the connected with Newton's third law, and I really want to, what do I really want? What do I really want? No, I really want to give you a technique, a trick that I've mentioned before, but I want to emphasize it, that will help make Newton's third law problems easy squeezy lemon peasy. But to do that, I mean, let's start with that trick. I'm not going to tell you what I'm going to tell you. Let me just tell you. Here's the trick. Every time you specify a force from now on, you have to do 3 letters. The first letter is the kind of force. You remember this? The second letter is the thing that exerts the force. The third letter is the thing that feels the force. Now, to make this machine gradable, we need to have a convention that you use letters, not words, for this, and you use the letters that I specify are allowed to be used. Let's give an example. I am going to have you specify a force or write down the name of a force in a particular way. Imagine this is the surface of a tabletop. I'm also going to say that somewhere under the tabletop is the center of the Earth. So I'm reminding you, hint, 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 that the planet as a whole can do stuff. What can it do? What kind of force? Weight force, obviously. Okay, so here's a tabletop, and here is your physics textbook. And I'm going to call the physics textbook P. And I'm going to put my coffee cup on it, and I'm going to say my coffee cup is letter C. One example of how I want you to be able to express these forces, at least for entering into the Google form, is I'd like you to be able to tell me that the physics book exerts a force on the cup. What kind of force would that be? What kind of forces do we know about? Yes, that's it, right? Solid-solid surface interaction. What's the first letter of normal? And what is exerting the force when I say the physics book supports the cup? The physics book exerts the force, and what feels the force? The cup. So you would say, instead of what many people have been writing, the normal force, or just the force, or just whatever, of physics book on the cup, that's what this stands for. I want you to start being able to type in NPC. Normal force of the physics book on the cup. Nothing to do with non-player characters. Yeah? I write these, by the way, with subscripts. You obviously can't type subscripts into the Google form, but I like to, and I encourage you in your notes so that they look like mine, to write and PC or little. Sound good? Yeah. So what I'm going to do to make sure that you can answer it correctly, according to how I'm saying, is I'm going to tell you what letter to use for each thing. Right? Physics book is P here, cup is C there. If I add a biology book to the stack, I would tell you that we're going to use B for that, or whatever. Okay? Okay, let's test this. I've been signed out, signed in again. What the balls? Okay, let's test this. This one won't be for points, but I want to make sure that you can do it. Tell me how we would describe the gravitational force on the physics book. So Google question B. B was not NPC. I didn't tell you to write that. Google question B, bravo, is to tell me how would I write, what symbol, three symbols would I write for this sucker's gravity? You could talk to your neighbor, by the way. By the way, if you're on Zoom, you can absolutely see you can see the freaking what? You can see the picture of me in front of the whiteboard if you look at if you look at what's it called? On Zoom, you can look at the individual people talking as well as what's being projected. What's that freaking called? Here, look, where it says, if you have to attend class on Zoom, by the way, don't do this. You can click this box and select who you want to watch. Where is it? There we go. That dropped down. So you can see in this mode, you can absolutely watch me. And if I walk over here, takes a second to scroll. Oh, there. Wait, where are we? Where is it stuck? Pan. Oh, it doesn't help that I've got the lights off. Hey, so tell me honestly, the people who are here on Zoom, did it not actually pan over correctly? I will try to keep an eye on that. I'll leave this sucker up here. I'm gonna pin this. Well, no, I don't want to pin it that much. It does pan over. Good. It also helps if I turn on the lights. Now, how do I freaking return this to its original size? No, no, everything is ruined forever. Oh, for dog's sake. Y'all enter the way that I've been talking about gravity in here. I will turn on the lights. I will maybe reopen. Switch to shared content. There we go. And I'm going to pin this sucker. No. Oh, balls. There's a way to make this pop out and not be tiny. So you can actually see it, but also see the real screen. There we go. There we go. Okay, so if you are having trouble seeing both, go to View, Speaker, side-by-side speaker, okay? But also don't go to class on Zoom. I will leave this up so I can keep an eye and make sure that it's panning across when I do things like that. I will also tell you that the correct answer for A, just in case, to be fair, since I haven't taught you how to do that yet, correct answer for A is the number 3. Just the number 3. Just the numeral. Also, the correct answer, no, you know what? If you weren't there for this, then you attended late, whatever. Okay, so, what is the name that I've been using for gravity all this time? Weight force. That is the universal, constant, consistent name I've been using. Have I been calling gravity? Gravity for me is the title of a chapter. Gravity for me is an idea. Gravity is not the name of a force for me. Some textbooks and instructors will talk about gravitational force. I prefer to call that by its simple, short, easy name, weight. So what I was looking for is W of what? What is exerting the weight force? Earth. Earth is the object. Hint, hint, hint. Earth is the object that exerts the weight force. And what was I talking about? Feeling it? P. Physics book. Physics book. That's right. So what I was looking for, you don't need to change your answer. B is not the graded one. The weight force, the gravitational downward thing that P feels, is the weight force of Earth on physics. WEP. Not GEP, and very importantly, not WPE. That's how hard the physics book pulls up on the planet. WPE and WEP are very different. Well, no, Newton's third law guarantees they're the same, but WPE is the wrong answer for what I specified. Okay, your next task is not to tell me the full force name. Remember what I'm saying. This convention is going to be very important. We're going to use it a bunch. I'm going to test you on it. But I want you simply to practice figuring out what can exert forces on what. What is either capable of exerting a long-range force, the Earth, or is in contact with other stuff. Remember, all forces other than gravity this semester, all forces other than gravity are contact forces. They must be touching in order to exert a force. Here's how I want to see your answers entered. Give me a comma-separated list of alphabetized things that can exert forces on P, physics book. Okay? So you're going to tell me one letter for each object, separate by commas, and alphabetize them. ABC order, yeah? Making sensey? Include every object that can exert a force on P. And yeah. Do you know what I'm asking for? If you don't know what I'm asking for, you can raise your hand. Please, Fernando. In this picture, what are the things that you would include in a problem? What are the things that I would expect to include in a problem? Like, for instance, air. Buoyancy force, we haven't talked about that. There's no wind blowing over. Make the simplest set of assumptions. I mean, what letters did I even give you? And again, we're not talking about the full force names. I just want you to identify in terms of what the subscripts would be in the things that exert those forces. Mackenzie. What did I just say? Not the full forces, not the triplets. I just want the name of the objects capable of exerting force on P in this case. Single letters, alphabetized, comma separated. That is not the alphabet. That is not the alphabet. Okay, I have a couple of people telling me normal and weight. Those are kinds of forces. I want the identity of the objects. Your possible options are ETCP. Right? Okay, let's try this again. You may change your answer for C, and I want to see you tell me everything that exerts a force on physics book. Did I ask you for the words? No, I did not. I asked you for the letter so that this can, I'm training you so this can be eventually automatically graded. You must give me the letter, not the full word. Follow instructions, please. One minute. Turn to your neighbor and check them. Check yourself. Checkmate. All right, let's bring it together. Real fast, tell your neighbor what are the possible letters that could possibly appear in your answer. Real fast, turn to your neighbor. Tell them what are the possible letters that could appear. Because I still got people not following even that. Okay, did I ask for kinds of forces? Can N or W possibly be the answer? No. Good. Okay, let's identify. What objects are there? You should have said C, P, T, and E are the objects. Right? That's what I indicated the possible letters are and also pointed and also said it out loud. Now let's consider, is the coffee cup able to exert a force on P? Yes. What kind of force is that? Normal. They're two solid surfaces touching each other. Wave force is a gravitational interaction between planets and objects. The normal force of the cup is equal to its weight, but it's a different identity. All right. So bring it together. Yes, the cup can exert a downward normal force on the physics book. Should you tell me that it's a normal force? No, I wanted you to just give me the letters. Okay, physics book, is P part of your answer? Why not? It's the thing feeling the force. It's not the thing causing the force. Remember, you can't exert a force on yourself. Am I flying? I'm trying real hard to fly. You can't exert a force on yourself. Is T capable of exerting a force on the physics book? What kind of force? Normal force. Is E capable of exerting a force? What kind of force? Weight. I want you to call it weight, not gravity. Okay, so the correct answer, and we alphabetize C, T, and E, becomes CET. CET is the correct answer, as about 90% of you got. Good, let's do another example. Tell me all of the forces that interact with the coffee cup. Tell me all of the objects that can exert a force on the coffee cup. Just object letters. No typey words, no typey kinds. Just tell me the objects. Alphabetized. Yep, this is an important date and an important lesson. A whole bunch of wrongo. What? Okay, 1 minute. You may turn to your neighbors and check them. I want comma separated values. That's right. Letter, comma, optional space, letter. I'll be more specific about spaces later. All right, this is an important lesson. I got 75% of you there, but I want everyone here, or at least to get to 90%. One more chance, Henna. I want you to do the exact same thing that we did in the previous exercise, except for the coffee cup. Tell me the things capable of exerting force on P. 5 seconds. 4, 3. C, 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 C. Yes. 5 seconds to do the things on C, Hannah. 5, 4, 3, dos, eins, 0. The correct answer, let's see, what is possible to exert a long-range gravitational force? The Earth, right? Okay, the other object in contact with it is what? B. Is the table capable of exerting a touch force on coffee cup? No, absolutely not. The correct answer is EP, not EPT. Just EP. Okay? Let me emphasize, the table is not touching, so the table cannot exert a force. That doesn't mean if the table weren't there, the situation wouldn't be different, right? If you took the table away, the cup and the physics book would fall, sure, okay, great. Then the situation, yeah, that would change things. But the table going away means the table no longer exerts a force on the physics book. The physics book would no longer exert the same force on the cup. It's the physics book that pushes on the cup. The table does not push directly on the cup, therefore no force. Okay, let me give another follow-up to this to help push this through. Where the balls did I drop it? There it is, I dropped it. Dropping the ball, or the pen. Okay, here's situation number dos. Scale S, person P. Oh, elevator E is going to be bad because elevator and Earth have the same. We'll be British and call it L, lift L. There's a planet nearby. And I'm going to say, let's see, cable? Sure, cable. The object, the system is moving upward at constant speed. Let's say that. No, damn it. System is moving upward with an acceleration speeding up. Okay? Speeding up in the upward direction. Tell me about everything. Okay, questions on the letters. Tell me all of the forces and only all of the objects and only the objects interacting with person. Alphabetized, comma-separated list of letters only. Yeah? Great. All the things that interact with P. I'm going to zoom in here. Other than the Earth, which hopefully is obvious. What's T? There's no T anymore. Yes? S is the scale the person's standing on. Not all of it's on. But that one's thinking. That was another hit. What does it say to start with? No, but the other one is not up there. Okay. Less than a minute. Time's up. Nobody said acceleration. Yes. That's not an uncommon goof to make, to think that acceleration is a force. No, acceleration is the result of forces. But no one made that mistake, so I'm preaching to the choir right now. All right, let's go through our checklist. Is there a planet nearby? So what object should I include that exerts a force on? Earth. I had like 15% of you miss the Earth. Don't miss the Earth. If I care about the vertical direction and there's a planet nearby, unless I specifically say deep space, E is always there. What else is touching the person? The scale. Is the lift touching the person? No, the lift is not in your list. He no touchy. Here's the lift line. Here's the person line. There's no contact between these two objects. Okay, turn to your neighbor and you explain to them and they explain to you why the correct answer is and only is ES. Teach each other. Only wait for no touchy feel. If the only thing that gets you touchy feel, you would wait. Then the lift could exert a force. Totally. That's not this diagram. You know what? Maybe I'll include that just for the hell of it. Sure, let's do it. I got a couple of variations first. Okay, follow-up questions on this. You guys feeling more comfortable with ES? Great. Tell me the objects that can interact with the Earth. Of these, which objects can interact with the Earth? Question F. What is everything that can interact with the Earth? Getting better. You might want to consult the alphabet, by the way. I've got a number of alphabetization errors. You can put that on your equation sheet if you want. Write your ABCs. All right, I'll take it. We're getting there. It's not perfect. I'm going to do a couple more examples, but everything that has mass, which is to say everything, feels a weight force. Now, when we discuss tension more, I'm usually going to specify a massless cord, a massless, stretchless cord for reasons. In your lab this week, you're going to be using a string, and you won't need to account for its mass. If you already knew that and neglected C, all right. Actually, I don't think anyone did neglect C. People neglected L and C together. The person has mass, the scale has mass. Elevators don't have mass? Yeah, they do. Okay? Correct answer is clips. Everything, CLPS, all of these objects can exert a weight force on the Earth. Okay? Google question G. Everything that exerts a force on the lift. Everything that exerts a force on L. What a trick question. I mean, every question's a trick question until you understand it, and then it's an easy question. Everything that exerts a force on lift. What's G? Again, all the forces that act on, all of the objects that exert a force on the lift. Again, please check that you're alphabetizing correctly. I can read this, but my program cannot that I'm writing. There is no W. Look at the letters, please. And this is Google Form G. Okay, time's up. Okay, I've got down to still, again, 75% of the class. Let's work on this. This is an important skill, and if you don't learn it, you're dead. You cannot possibly do Newton's third law if you can't identify what touches things. Okay, does the lift exert a force on itself? You can't push yourself. No. Does the person exert a force on the lift? Why can't the person force the lift? No touchy. These lines don't interact with these lines. Also, what we did before when we found the forces on the person, I said the lift does not exert a force on the person because they no touchy. Remember what I say, by the way. It is strongly suggested that you listen to and remember what professors say in general in college. Can the scale exert a force on the lift? Yeah, of course, they're touching. Can the cable exert a force on the lift? They're touching. Can the Earth exert a force on the lift? Yes. What kind of force? Weight force, exactly. So I still have a whole bunch of CSs, and that's not a major offered on this campus. So let me encourage you, unless you're a computer science major, don't forget about the Earth. Just because I zoomed in on this picture doesn't mean there's no planet nearby. What the hell? Let's take the planet away. Here, outer space. Zoom, pew, zoom. I'm in a rocket ship. And the rocket ship is accelerating. So I've got a chair. They don't actually do them this angle. And I'm in my chair. Chair, person, rocket. I'm being accelerated upward. I'm sitting, or in this case, it appears that I'm standing. That probably violates NASA standards. Standing on my chair in the rocket. Rocket's going through deep space, way far away from the planet. List every force acting on the chair. List every object interacting with the chair. I keep saying it. Keep jumping ahead to the next thing. Until we get this, we can't. Yeah. Every force acting on a chair. Again, every force that acts on the chair.
Oh, that's valid. That's a valid point.
This is Google form H, by the way. We are on H, not I. H. If you put it in the wrong form, you're going to lose points. Dose, too, also. Okay, you got like 2 seconds left. That's progress. 90% correct. And I think at 90% correct, this is where I say, if you're missing this, you need to work with each other, talk to a tutor, or ask me for help during office hours, because I'm moving on now. I'm not going for 100. When we get 90% or more, you need to seek outside help, okay? The correct answer, touching the chair. We look for lines touching the chair. There's a person, P is touching the chair, and there's a rocket touching the chair. Is there an Earth touching, gravitating? I specifically said deep space far from any gravitational sources. No E, no Earth, okay? So the correct answer is PR. Viva Puerto Rico and the person in the rocket. Okay, now what? Now let's talk about the full force names. I want to do the same thing, except instead of just talking about the object, I want you to give me the full name. That is to say the 3 letters, the kind of force, W, N, F, T, and what's the last one? S, thank you. S? Wait, what's S? Spring, right. The kind of force for the first letter, the thing that exerts the force for the second letter, and the thing that feels the force for the third letter. Give me every force name separated by commas for the person. Correct answer has 3 letters, my peeps. There are 3 letters to any force. To each force that you believe is acting cannot possibly be exerted as a single letter.
No commas, right? Like together.
No commas within the force name. If you believe that there are 3 forces, there would be what? 9 triplets of letters separated by commas? 9 letters and 3 commas? If you thought there were 3 forces? If you think there are 2 forces, there'd be 1 comma between 3 letters and 3 letters. Wait, if there were 9, it would be 2 commas. Whatever. Okay, so you need to decide on the kind of force, the cause of the force, and the effect of the force. And if we get to 90%, we move on. Again, there are 3 letters to each force designator, not 2. And when I say a force designator, I want 3 letters put together, no commas between every single letter in the sentence. And no parentheses. Again, I'm teaching you so that we can specify this for a program to read it. You have to follow directions. Okay, 1 minute. Got a lot of blank answers here. You may turn to your neighbor and discuss, and please have them check their formatting because there are a whole bunch of people not writing 3 letters, possibly set with commas together. Again, I am asking you to write 3 letters for every force acting on the person. The first is the kind, the second is the cause, the third is the thing that feels the force, hint, hint, hint. No periods, please. 3 letters together means nothing in between those 3 letters, my dudes.
No, Chris Paul? Bro.
Okay, let's pull it together. It is time. We're at 80% again. So let's review. What's one problem with N period P period C? That's not what's wrong with that answer. N period P period C. What's wrong? Why is that a wrong answer that won't receive credit? What did I specifically say about the format for specifying the force? Yeah? That is one fact. Yes, if I'm talking about the force on the person, the third letter which specifies what on the force is on should be the P. What else is wrong with N period C period P? N period P period C. God damn it. Yeah, N period P. Periods, exactly. What did I say about the format? No separators, 3 characters together, then a comma, then other forces if that applies. Yeah? Okay. What's wrong with WEC? We're in outer space. I specifically said in the previous problem, there's no Earth acting on the chair. Why would there be an Earth exerting a weight force on the person? We're in outer space, deep space, far from any planet. There is no weight force. What about SRP? What's wrong with talking about the spring force that the rocket exerts on the person? There are a couple reasons why SRP cannot possibly be one of the forces. What's wrong with SRP? The person is not touching the rocket. And where's the spring? There's no spring in here, right? There's no spring. Okay, so we got 80% of you saying NCP. That is the correct answer. But again, I want to hit at least 90% before I'm going to move on. Let's do another example. Here is a ceiling. Here is a string. Here is a pendulum. Well, the whole thing is the pendulum. I should use the correct name, which is bob. The thing that is the big mass on the end of the pendulum, that's a bob. And the bob is swinging back and forth. Whee! Okay, swings back and forth. Whee! I want you to identify everything that exerts a force, everything that exerts a force. We'll talk about the full force notation in a second. On the string. everything that exerts a force on the string, and let's say it's a heavy string for now. I have not yet told you about massless strings. Yeah.
In outer space.
No, if it's swinging back and forth, it can't be. It's on Earth, yeah. This is a pendulum. I have not specifically said deep space, okay? One more time, we're not in deep space.
We'll compare. This one might.
You will get the answer wrong if you put this in K. One more time. We are on J, and if you are putting your answer in the next slot, you won't get credit. Once I start hooking this up to whatsity. I want a comma-separated list of the things that exert forces, by the way. Comma-separated list of the letter of each thing that exerts a force. And alphabetize, always, otherwise the grader won't get it. In J. You may consult an ABCs chart if you need. Okay, and that's, no, I'm going to give you one more minute. We still do have a lot of blanks here.
Actually, there's I'm still gonna go one of the two. But it's like every step where like on a by. No, I'm good. So I have won 4 times in multiple. Then the second person has won like 3 times. So I'm still gonna go.
If you put this in K, you will get 0 credit. Again, I'm asking for the objects. I do not look for the triplet notation. I am not asking for the kinds of force. One more time, the question is, I'm asking you to specify the objects by one letter each that are interacting with the string. I'm pretending the string has mass, by the way. I'll kill that later. Okay, let's say time's up for this. Oh, Aiden asked, does it matter if we're in all caps? No, it's very simple for me to program something that kills the capitalization. So caps or lowercase, yeah, whatever, doesn't matter. Okay, let's go through and learn from mistakes. The correct answer is B, C, E, or I should be precise, B, comma, C, comma, E. Let's learn from mistakes. Why is B, comma, C, comma, S wrong? The string can't put a force on itself, and I didn't say deep space, so you missed an E. Right? I said specifically they were going to say that the string has mass, which later I'll say is we're almost always going to ignore. String can't force itself, and you're near a planet, and you've got mass, so there's going to be an Earth exerting a force on you. Why is BC wrong? B comma C, what's missing there? You missed the Earth. What's wrong with C comma E comma B? It's not alphabetized, okay? Are we at 90%? We are at 84% correct. Let's keep practicing until we're getting to 90% of the class correct. List every object's name letter that interacts with Bob. Hi, Bob. What interacts with you? This is in K, by the way. No sympathy if you put this in a different column. What interacts with Bob? Hi, Bob. Getting there. What interacts with Bob?
Yeah, elongated septum. Yeah. Emotional soft mute. This one won't go. It's not too apparent.
1 minute. Arr. Again, one more time. The question is, as my 3-year-old son said, what are the objects that interact with Bob? Give me their letters in an alphabetized, comma-separated format. Exactly as we've been doing this whole time. 1 minute left. Time's up. And that's 90%. The correct answer is E, comma S. There is a planet nearby. Don't forget him. There's a planet nearby. So it's a weight force on the Bob. There's a string touching him. Is the ceiling touching Bob? If he no touchy, no forcey. Unless it's big enough to be a planet, it has to touch. Okay? I had several people say B. Why is B not a possible option? You can't force yourself. I had a couple people say S. Why is S wrong? You forgot the planet. Every pendulum I've ever seen. No, I didn't say you're in deep space on a rocket or whatever. Unless I say that, I'm talking about vertical directions here. I care about gravity, so include a weight force. Okay, we're at 90%. I'm moving on. Now, let's repeat the exact same thing, except I want you to give the 3-letter specifier for the kind, cause, and feeler of the force, okay? Make sensey? Tell me about the forces that act on Bob, not just the things that act on Bob. Separate your triplets of letters with commas. What are all the forces acting on Bob in the triplet notation that I'm talking about? Again, triplet notation. Each of your forces needs 3 letters. The kind, the cause, the feeler. One minute. Comma separated list, my peeps.
What you mean by that? Dude, just because it's up till then, it doesn't mean you can become a freak over. Every day, I'm gonna be something for. That's why I shaved. I'm sorry.
Hey, 1 minute. Typey, typey, fasty, fasty. Give me what you got. What you really, really got. And now it's time for me to grade. You can see where the class as a whole is. Not words. Oh my God. Comma separated. Oh my God. Okay, time is up, and we are back to 75% correct. Let's list the objects again. What objects possibly interact with Bob? String and planet. Is the ceiling touching the Bob? In the previous example that we just did the ceiling exert a force on the Bob? So why are you still including forces that the ceiling exerts on the Bob? Look at the previous answer. It has to match. Okay. The correct answer, by the way, is T, but let me get it right, TSB, comma, WEB. Let me write this again. TSB, why you know scroll? What the balls? TSB, comma, WEB. And how do we read this again? This is the tension force that the string exerts on the Bob, separator, weight force that the Earth exerts on the Bob. Yeah. What? Well, I didn't remind you of this, but yeah, I'm going to say in general alphabetize. So for instance, T comes before W, so this is the order that I'd look for. Yeah. Yes. Mm. So spring force versus stretch versus tension force. The distinction that I make is if you care about how long it's getting. The problem statement that I gave was it's a string and a pendulum on the string. I gave no hint. The words do not include anything about the string being elastic. If I meant to include that, I would say a stretchy string. Keywords are stretchy string, an elastic cord, a wire spring. How else would I say this? Um, a stretchable string. These are all hints that I would want you to include. This is a spring force. Or if we're doing this numerically, we will eventually get to that. If I start talking about how much longer is the string later, if I'm talking about that, then I would be caring about the stretch of the string. Yeah, good question. Okay, now, uh, uh, we're at 75% of the class. I would like to see about the 25 of you missing these. Give me a hint where I'm losing you. Tell me what's confusing here. Google question M. By the way, you do not have to say I understand, okay? Don't say nothing. If you can tell me where you are struggling, tell me what's confusing about this lesson so far in Google question M. M for mm. Mm-mm-mm. Show me where I'm losing you. You don't have to say NA. I just said that. It does not have to be alphabetized for this. Ah, okay, great question. Why is there no normal on the Bob? You tell them. Why do we not include a normal force? What's exerting the normal force? No, strings don't exert normal forces. They exert tension forces or spring forces if we're talking about an elastic string. Okay, so one answer is because the string is a string. Strings, ropes, chains, elastic cords, rubber bands are all things that we call tension forces. Normal forces are walls, fingers, floors, ceilings could exert normal force on another object if I'm pressing against the ceiling. Okay. Someone said I was confused about the wording of the question, how you wanted to have it formatted, but you got it right. Okay. Okay, again, I genuinely understand is incorrect. I told you not to say that. Why do we not have normal force? Again, because there's no solid surface touching it. The only thing touching it is a string. Okay, why isn't there normal force on Bob? Again, I need a clarification on the different types of forces. Here are the only 5 things that we've got so far. Weight, normal, tension, spring, friction. Okay, go back and look at 2 lectures ago. Was it 2 lectures ago? 2 lectures ago when I gave you this dictionary. Weight, normal, tension, spring, friction. Weight is exerted by planets or stars at long range. Everything else is a touch force. Normal, 2 solids pressing against each other, keeping from phasing through each other. Tension, ropes that you don't care about stretching. Spring, things that do stretch and are long and stringy. Friction, 2 solid surfaces keeping or trying to keep from rubbing over. Do we have to put spaces? As I said, I didn't say this one. I will eventually maybe have you do that, but for now I don't care. I can sort that out programmatically. I would like a list of the forces. There we go, just did. The way I say the 3 comma things are confusing. The 3 comma things. The 3 commas, there aren't 3 commas. There are 3 letters. Each of these forces that we're specifying have 3 letters. Again, the first letter is the kind. The second letter is the thing that exerts. The third letter is the thing that feels. And what I want is them 3 put together, 3 letters put together. You also got that almost right except for putting spaces there. Why is there no normal force on Bob? Answer that. Confused about objects being stacked. Talk about that later. Why is the weight force only included or only when there is a string? Does weight force depend on strings? There's no string on me. I feel a weight force. When do we include a weight force? Anytime I don't say deep space and I'm talking about vertical forces. If I care about the vertical direction, if I'm just talking about, moving left, right, I don't care about weight yet. But if there's an Earth, which is going to be always, unless I specifically state deep space, it doesn't depend on having strings, doesn't depend on having anything. There's an Earth force. When we use this answer format, TSB, WEB, whatever, what did I call it? I call it triplet notation, fully describing forces. And this is not, by the way, this is not a scientific standard. This is me trying to see how many people who is identifying kinds of forces and objects exerting. Sometimes the wording of the question confuses me. I'm not sure what part I'm confusing you with. Here's another good question. Can objects only have one force on another object? Sorta. Friction and normal can coexist. Friction and normal are actually just parts of one bigger force called contact force. I'm not teaching you about contact force. We're going to treat friction and normal as 2 separate forces. The table can both friction and normal an object sitting on it moving along it. Other than that, you can't have both a string exerting a tension and a string exerting a normal. Also, strings never exert normal. Just the formatting. So forces are only happening when the objects are touching. Question, so forces only happen when objects are touching? Yes! Except for weight. Weight can happen anytime there is a long range thing. Okay, it would help if you restate the order of the triplets when you ask a graded question when I forget. Write this down in your course notes. Kind, what's the dealer and feeler? No, I don't like that as much. It's a little, what's the other way I put it? Causer, thing that exerts, I want a single word. Damn it, it's dealer because I can't think of it. Write this down. If you're having trouble remembering this order, the kind is always one of these letters. The dealer is another lickable object in the room, in the vicinity, or the earth if we're talking about weight force. And the feeler is always the thing we're identifying forces on. How do you know if it's spring tension or regular tension? There's no such thing as spring tension, there's spring force. So I'm going to uniformly refer to it. Okay, confusion. Is it the part where we get tension and weight? And how do you know when to use certain ones, like how we use both tension and weight separately? Again, here's the routine. You look at, is there a planet nearby? If so, include weight. Done. Look at what touches the object. If it touches, it might exert a force. Use the dictionary. Well, if it touches, it's one of these kinds. Again, normal is solids pressing against each other. Tension is ropes. S, spring is if it's an elastic cord or whatever. F, friction if the two surfaces are touching and rubbing. That's it. That is the entire algorithm for finding out when there are certain ones. My explanations are sporadic. I'm not sure how to answer that. For the triplets, is it kind, cause, thing? Yes. Letters are confusing me. I'm not sure how to answer that. We need some time to adjust. Okay, I'm giving you 2 classes of it. Okay, some people might be getting lost because the object we're supposed to be observing is touching another object that is touching another object. So they might think that the object observed is somehow connected to the object they're not touching. Okay, that's a point. If A touches B, which touches C, A does not force C unless the lines of A and the lines of C are in contact. If they are touching, if they are right next to each other, if they are adjacent, then there can be a contact force. If there is something between two things, no direct contact, unless one of them is the planet, then no force. There are multiple ways to deal with this next example. How do I want to call this? I'm just going to call this A and B. And I want to make these boxes. Box A and box B are connected via a rope that goes over a pulley, and there's some distance above the ground. Again, so there's a pulley, a rope, and 2 boxes. This is what we're doing in lab starting tomorrow. And they're above the ground, okay? Thank you, Sensi. Look, I'm almost forgetting the weight of the rope thing because it's so very common. Starting now, even though today isn't tension day, even though we're not focusing on tension, let me write it out explicitly. Ignore the weight of the rope. You'll ignore it in the lab. What? No, go away. Ignore rope weight. There. Is good? Okay. Let me make sure that we've got the touching thing improved, okay? Let's improve on the touching thing. Let's check when I introduce the kind of forces that seems to be harder. So let's start, just list the objects capable of exerting force on box A. This is Google form N, N for November. You may work together. And we're not in deep space. The forces acting on box, what? Did I say N? No, Google form N. The forces acting on box A for alpha. You may work together. Again, I'm asking for the objects only, not triples.
Yeah, I do too. Right. Yeah. Gradually, reflexively. Yeah, and you're right. No. No. Yeah.
One more time, we are near a planet. That planet is capable of exerting weight forces. I will also point out that I have always consistently been distinguishing from floors and grounds and surfaces and planets as an entire bulk. If you take away the floor underneath me, there will be no normal force. I'll fall, but there's still planet exerting a weight force. That's why I fall, right? So yes, the ground is part of the Earth, but the ground isn't, this floor is not the cause of gravity. It's the planet as a whole. So please distinguish from the E that we've been using consistently and the piece of the Earth, which is the ground. Excuse me. Okay, 1 minute. You've been to Jupiter?
You're not living life together.
I only stop at the moons. I like Europa better. I will give a hint. There is no S. Please read carefully. We have 10 seconds left for the people who haven't answered yet.
LTSI, bro. Let that. That's all I'm gonna do.
Okay, time's up. We're now at 88% correct. We're almost there. Is the ground touching the box? Can it exert a touch force? No G. Is box B touching box A? Box B exerts no force on A. What is the physical object touching box A? The rope. Is there a planet nearby? The correct answer is E, R. Okay, we're almost out of time. We're out of time. Okay. I would strongly encourage you to come to office hours on Wednesday if you are struggling with this. I'd really like y'all to understand, every one of you. I love you all. Goodbye. What am I doing? I'm stopping.